I will give a presentation of a paper called Spatial Performance Support Urban Ecosystem Services. And it's a research starting up, actually, to start. And it's done together with Lars from KTH, who is present, and Åsa Gray from the Bio Institute in Stockholm, who is not joining us today. But she is an important contribution because what we will talk about is quite something different than I think from other presentations we will present during this conference, because we try to, as is in the title, include ecosystem services, which is, let's say, trying to integrate the services that the green structures in our cities give. I will come back to that. To start with, I would like to introduce, let's say, why we do this. And it's important, let's say, I think it was said already in the previous presentation, that if you talk about sustainable development, sustainable urban growth concepts like smart growth, compact cities, most of, let's say, that direction, those concepts, they build on research findings related to reducing, for example, private car mobility, carbon emissions, air pollution, etc. You all know. Let's say high density, land use, diversity, pedestrian friendly design, they are amongst the solutions. And we talk a lot about that, it's important. But the focus is on mitigation, the focus is on trying to reduce, let's say, those bad things happening. But there is another thing, and that is when changes occur, which we maybe can't influence, then you need to adapt. So we should also study strategies for adaptation. And to do so, you need to address the resilience, let's say, of the system. How good is a system, a city, in coping with those changes that can occur suddenly or slowly. And what we say, and with a lot of others, is that we need to understand cities then as integrated social ecological systems. From that, we come to the ecosystem services. Because cities, they are dependent on ecosystem services. And when I talk about that, I mean things like trees in the cities that are important for evaporation of water, bringing down the temperature. It's also water in the cities that has those functions. Pollination is another one. So there are a lot of things, let's say, that the natural system gives to us, a service, that are extremely important. But the thing is that we know that. And we also know that they are threatened a lot because of urban growth. But what we don't know is how urban design and planning can influence that. So this paper is actually a start to start and describe from the beginning, let's say, to at least start a methodological approach. So how can we study this? How can we sort of include these factors in our studies and understanding of space, and then especially take urban morphology serious in that, because a lot of studies are being done. I will talk about that later. So in our abstract, in our paper, we say this. In a space syntax context, this implies an aim to develop knowledge about how the spatial configuration of cities not only deeply influences a series of urban processes of a social kind, but also a series of ecological processes, potentially thus aiming not only for a social logic of space, but a social ecological logic of space. This study does primarily concern the distribution of the green system, the green structures we have. So we talk about biotopes, we talk about green patches in the city. And these you can represent as networks, and it's done a lot. that's by landscape ecologists. And it's not for just the increase of doing this is because of a lot of fragmentation of the green structure going on because of urban growth. And that's partly the reason actually that we also have these new or this concept of compact growth and smart cities that I talked about in the beginning. The thing is that they don't drop down a bit, that they don't treat the green structure or the patches in a lifelike manner, or put it differently, that often urban morphology is not included, at least not in a detailed enough manner, to really help us as designers and planners and architects to really understand what is going on and how we can influence that by designing. So we start a model for, in this case, the ecosystem services for pollination. And the model should do the following. Our aim is that it can capture bee diversity and bee abundance, because bees are very important for pollination. So that's the species we look at. It should be able to integrate with other models that say something about other ecosystem services, and not least also, let's say, how we as humans use the city. So also health issues are part of that. And it should be effective in the comparison of alternative design alternatives, meaning that it should capture changes in the urban morphology in a good way. And there's a very important source for us is Pascal Portal, who actually tested all measures used now by landscape ecologists to do such things. I will in the following go through this model that we are building up like this. I'll talk about aging, the object, the representation, I will talk about distance, and I will talk about attraction. And of course, they are connected to one another, and defining the agents also says something about the distance. If we talk about bees, it's no use to talk about 10-kilometer distance because they don't fly that far. So there's, of course, a lot of relation there. We look at bees. There's different species of bees. And we know already from other research that urbanization in general is negative for bee diversity and bee abundance. Bee abundance, so how many bees we have at a certain area, is affected by local qualities, so how much green is there, how much different flowers, flower cover of an area, and bee diversity by contextual qualities. And in the research that we built further on, the contextual quality is mostly the amount of impervious surface, which is a very rough measure. As urban designer, it's very hard to work with that. And it actually says that cities, especially dense cities, they will not perform very well. And we sort of see that to talk about mitigation and adaptation, we need both. We need to compact our cities to have a more workable environment, but we at the same time need to be prepared to also have all other ecosystem services included. So what we want to do is that we also need much more knowledge about the distribution and the connectivity of these impervious and pervious surfaces, so the green patches. And these green patches can also be urban areas, villa areas, or a little bit denser areas that have impervious surfaces. Okay, the object we look at, and with object I mean, I will define that, it's the patches that I already talked about. So they're geographically defined components in the network. It's exactly the same as landscape ecologists use. So you have, very simply, you have a development garden, so that's one, could be one patch in the system. Then we have connectivity zones, and that's important to say that these are, let's say, to move for a bee. They cannot move through the street as we do, of course, or they can, but they mostly don't do that. And they don't fly through forests, but they fly along forests. So there are some biotopes that are important for the movement. They can be used for movement, but not for other things. So therefore we have two kinds of patches, you could also call them. But the one we define as connectivity zone in correspondence to what landscape ecologists use. And then we have barriers, and that actually all the other areas. Can be buildings, can be streets, but streets can also be a connectivity zone depending on whether there are trees or other green areas within the street. So then we have the map of Stockholm with all the biotopes defined. We know which biotopes are good for what part of the line of the bee. We know which ones can be used as connectivity zones. So that defines the object we use as a starting point. The other thing is, we come to distance now, is that, okay, we know the habitat area requirements, so the biotopes that are important. Then we have to look into the movement capacity, in this case for bees, but you could of course look at all other kinds of species. And in our case it's bees, and then we know the relative distances for the different types, or the different species of bees, is from 250 meters to 3 kilometers. Those are relevant. Above becomes irrelevant. Based on that, so based on the biotope map, we can draw, let's say, the object of our research. So all the green areas, the light ones, those are the biotopes that are used for foraging for the bees, where they, let's say, they find their flowers to let's say, their food, we could just simply say. And there are, so all these biotopes are included. The dotted green, those are the forest areas with more than 70% tree cover. So there they can't navigate through, but they can navigate along. So those are important as well. Then we come to the representation of the network. And as I very shortly said in the beginning, in landscape ecology, the network is defined as a patch. So this is a patch, and it can be defined, this can be composed of different biotopes that are relevant for bees, and then you connect them if they are connected, just by connecting the lines. So the patch becomes a node, and you connect them with links. Very different, let's say that's different from the approach we have in space syntax, where actually, because in this case, the link doesn't represent something real. There is somewhere a possibility that it's a link, but what it really is, and what the form of it is, we don't know. So we actually change the approach. So we start from the way space syntax represents the open spaces for humans. And we take the object, so we take all these green patches and the connectivity zones and draw an axial map in these areas. So we don't take the open spaces as such, we only take those relevant for the species we look into. And then it becomes something like this for the northern part of Stockholm. The last part is then, I want to introduce the attractions. And what I mean is actually what you talked about, is let's say the amount of people that you can reach within your network. In this case, that's irrelevant. In this case, it's important to know the area you can reach. So how many patches and how big are they in the reach of a bee? Giving him, let's say, more choices for the things that he is doing. So it should be included, and that's the way you can do it, is that you include, let's say, the attraction in the measure of distance. And what Again, we looked at what the landscape ecological research, what's done there, and what is thought of as the most important, of the most relevant measure for that, and that's the integral index of connectivity. And there is included the size of the patch of origin, where you start from, the sum of all the patches that you can reach within a certain distance, and the amount of links needed to reach that patch. But very familiar to a lot of you know. And then we looked at the location density measure that is used by Alexander Stoller in the PSD soft tool that Benedict talked about earlier. And that's actually simpler, because what's included there is, let's say, how much attractions or opportunities, in this case, how much area patch do you reach within a certain distance. And actually you could include that in that formula, and then you arrive at this formula. We can discuss that later if that's needed. That's actually, that's the whole thing that we sort of, the method we build up to start actually doing the research now, or test whether this works. What I showed you now here is just some images of if you use these two measures that I showed in the actual map that we drew on the green patches and the connectivity zones, and then you arrive at the darker the color, the more patches you can reach within the distance that's mentioned there. In this case, 6 axial steps and 3 kilometers. The 3 kilometers I described, the 6 axial steps, that's of course tricky, because how can we decide what a bee does? Is an axial step important? I mean, there are a lot of questions that are quite tricky in this research that we are starting up. And this is the other measure, the integral index of connectivity, and then on another distance. A lot of things are to see whether they are useful, if we can really work in this manner. But we think it's very exciting and I think important to include the green structure in the work that we are doing. So what we will do next is to validate the model, and we're very happy that we have data. We can use data from the university in Uppsala, Agricultural University. They did already research in Stockholm in 16 allotment gardens. So we can use that and test whether this gives information that can be relevant for urban designers also. That's one thing. And then if we do that, of course, we have to go back. Okay, the distances that we talked about, the drawing of the actual map, is it detailed enough? Because now it's based, let's say you can of course go much deeper and put all the trees in it and see what the importance of that is. Now we worked on the biotope map that is available. So we can go back to all the steps that I explained earlier and see whether we can change and adapt and see whether we can build up a model that works and explain something about where the bees are and where they are not. And then, if we can do that, we can start talking what the impact can be for urban design and planning. Because I said in the beginning, that's part, in the end it should be able to, you have to translate it back to interventions that you do, and then see what the impact is on, in our case, the bee diversity that you can reach. What will do this? How important is it to link this? Or here? What are the effects? And actually, here in Seoul, there's a very interesting example already of such an intervention and creating a very, very long green line in the city. So we don't know how it will affect, in this case, what we are interested in now, pollination, but a lot of other ecosystem services could be tested. Now it's a beautiful area. And I noticed, I run there a morning, jogging, and a lot of birds. It's extremely, you hear birds everywhere there, with all the high-rise around you. So that's promising. Thank you. Lars will join me in answering the questions. Yes. Go on.
Me?
Yeah.
Thank you. Very interesting to take this analysis to another domain, but as you pointed, very relevant domain in terms of planning and design. My question is regarding the methodology that I think it's very useful to start analyzing this using the network models that we use. But I think it also requires a very big reflection if the existing tools, so the approach is adequate, but the existing tools, such as the XLI, are they still valid for such a representation? So that's,
yes.
I think it's important to give this step, but now the next step is also the reflection on what methods and what models are adequate.
Absolutely, I totally agree. Let's say that's a huge test. If it would be the case that it can shed light on, let's say, also these issues, then it would of course be very, very good if you can use the same approach, because then you can start to sort of build upon each other instead of making different models that will. I mean, because I think that now we look at pollination, and if we then start looking at another ecosystem, so we need another model, and again another model, and then we have to combine all those. It would be, let's say, I'm always convinced that the most useful solutions in the end are those that are the most simple and limited ones. So if we can have one model for a lot of things, that's better than if we have 3 models for it.
I agree that the network model as a general model can be used for everything. My main issue is the syntax axial line has been developed for a very specific purpose. And I just wonder, and I'm not saying a different model that is not a network model, but maybe you can combine different network models together.
Because I totally agree also that, but I also, because see it as a way of reflecting on the axial line too, and the general modeling in space syntax. So see it as an example, so to say, what is discovered in space syntax is not just one thing, it's a family of things. It's a kind of I would, for example, call it a kind of a cognitive geometry, you know, the axial line is a cognitive distance. But then it raises the next word, okay, so then we're talking about actors, and they can be many. We're already there when we start biking. We're not the same person when we bike as when we walk. And then if you move over to bumblebees and all that stuff. But, so of course, but I think from a very theoretical point of view, I think it's an opportunity to reflect on space syntax modeling by seeing the larger picture, where we have an example of an in family rather. And sorry, but I was kind of excited about this. But also the other thing, but I also agree with, of course, I think that the modeling in space syntax is tremendously economic. And at times it's so economic that people don't realize all the stuff that's in there. So we need to unpack things at the time. And that can help too. And one of these things is, of course, that we do have in our back of our mind. It's not like there's so much modeling going on complex theories and everything, so complex systems. But in the modeling of space syntax, it's done from a particular point of view. You want to actually, it's from the point of view of urban design, right? So you have one. You want to pack. You can't do 10 designs for everyone, all the different actors. Yeah, put it back. And of course, it will be more difficult when you start to add different birds. But maybe, humans are also rather heterogeneous and diverse, and still we build one city in the end, and are able to carry all that. So maybe we can carry a lot within, and at least start to explore what we can find within a similar spatial structure. At the moment, we're not doing that simply because we haven't thought about it. So we destroy a lot of opportunities that could be there where we could combine these things. That's. But I agree, all the. Sorry.
Well, my question is partially answered, but I'd like to make a comment on still the axial line issue. I mean, there is some opportunity there also. I mean, when you look at the bee behavior and you look at this diagram showing the various bee types at this a range of the fly zone or flight range. So, I mean, it feels like there's another kind of opportunity to model their behaviors with axial line, whether it's some sort of convexity, if they fly range can be used as a language. I mean, it's just a small, it's a comment perhaps, but the main idea is that how can we how can we define new modules based on the type of behavior or some, looking at the language of behavior and then take that into the model rather than apply the same model in the approximation or abstraction. So that's what I was suggesting. But we can discuss more perhaps with something different. But I'm also curious, how did you decide to look at bee behavior? Why bees but not something else? I'm just curious.
Well, actually, it starts with pollination, so then you come to the bees. You can also take birds, they're also important for pollination, but bees are more important. We could have, we could have taken another, yes, we started from somewhere. Actually, it's more to look into the possibilities of this, whether we can arrive. Because I think it started a bit from the fact that we are starting to see the importance of green again, I would say, in cities. But it's very much focused on area solutions. And we forget about that doesn't help so much. Maybe in the end, I would say it will not. It will give green views, and it will also clean the air probably a bit more and lower the temperature. But especially, let's say, for species that move, it's very difficult. So I think that there is an enormous need to come with something to give answers to urban designers and architects to include this in a good way.
It's fascinating research. I mean, that's also kind of bridges the gaps between landscape architects thinking and urbanization thinking, because they look at biodiversity and green ecosystem, green infrastructure, but they just, for them, look around this impervious surface. That's it. And
exactly.
Kind of
but we will work together with people that are very much in that field, so they will help us in solving those issues. You can also have a question,
It's a comment really. It would have helped me a lot if there was an explicit statement before launching onto the axial map. What are the properties you're interested in? Verbally, you seem to be saying you're interested in how much space is available, green space, at what distance and with what connectivity. Am I right? Yes. The more you articulate that, the better it gets. So suppose that I am right for a minute. Then why, for example, not use straightforward, let's call it depth map visibility analysis, where you run distance and you run thirds and you have the information without reducing the system to any set of axial lines. I mean, I don't know, I'm not suggesting you do that, but what I'm saying methodologically is that there is a missing step, and the missing step is to actually write down in English or in math, I don't care personally, what is it that you want to measure? Because, for example, there might be some beast that manages to fly from green to green over non-green spaces, and then of course the connectivity function will be different. In this case, you need connectivity through the green, I understood that. But for the sake of discussion, why not use tessellation analysis in depth map? Flat filling it with time.
It comes back to the
same question. That's true, yes.
Just building upon the previous comment, by the way, very nice question and quite fascinating. Again, I think it has to do with the behavior of the species and how these measures reflect that. Meaning, if I understand these correct, I think the flying distance is key over and above change of direction. So you could have used measures like metric reach, or you could use a measure of compactness of a complex shape. And these actually don't necessarily have to be built on axial analysis rather than segment analysis or shape analysis. Or you can say, well, probably the squirrel, it depends on direction change. I don't know, but I think it has to be tightly related to the behavioral conditions of these animals. And
that's what I mean with the cognitive geometry. So you need another geometry, of course, for bees. You can do the axial map, so if we summarize this kind of the humans, but then we need another.
But these measures, I think, exist, so it's very easy to apply these.
Exactly. There's lots of spatial cognition for animals.
Isn't the axial line being used because it's open spaces and you want to have a something which
But it doesn't have to be an axial line, you see, because axial line implies the walking or flying in a given direction.
Yeah, no, but even if other like network representations.
Generally, the more open the space, the less well defined the axial map is.
Yeah.
Exactly.
So I agree with John. Probably the first thing I would represent this as tessellated tiles, and I would probably run a shape analysis based on the degree to which the shape departs from the circle or from the square, the way it becomes fragmented, hence the metric distance. If that relates to, again, the main behavioral B, which is covering distance of a flower to another flower, I don't know, but...
If I may add something, I agree with both of you. It's very good, and it's good to. First of all, it's very good to use the models that we know from space index, and we traditionally, sometimes have a narrow field of expanding something. So I really like the use of the models and the ideas that we know in something completely different. And then I do agree with the PGA for some reasons, but I also agree with the axial line, because they took it a step outside towards the right. Towards the left, you can go and deconstruct the axial line into the underlying graph, which is a very, very simplified one. And of course, you can find measures that might be, with the knowledge of space syntax, applied to something else. So I think we'd have to start. I had the same issue with some of my work, looking from inside out and not only from the core that we are further inside. So, but I do agree. It's not that I disagree with the comments, but it's excellent to open up a completely different door, if you get measures that initially they seem, of course, we can't be in the eye of a bee, even though we would love to, probably.
But there are lots of such modeling going on also. So, but there's there's
it's a very big conversation, a very nice one.
But I think the bee is a sort of a figurative tool. In fact, we need new models for metropolitan cities. So we cannot go on expanding, and sometimes there is a collision between green belts that are required, that should be preserved, and the extension of the city. So, in fact, we have got to deal with extension and intention. I mean, extension is the expand of the city, and at the same time, how we go on growing in density, and some green spaces are necessary. And incidentally, my experience of Stockholm, living there for a few weeks doing research, is superb. As I can see, probably is Seoul, but other cities are not. So we have got a point there, which is both a space syntax but also a professional issue. Which is the model for our future cities?
Who's giving the next presentation? I think we have to. Is that okay? Yeah? Because otherwise we only have 25 minutes left.
May I add one thing? One could ask, why should one do this? And then, as a matter of fact, the bee species are threatened in Europe at the moment. and the cost, they do a work yearly that amounts to, I might mix up the zeros now, but I think it's like 10 billion euros a year if you would go for 100 million. So it's a tremendous amount of money.
Same in the States, in North America, there's a big problem with it.
So it's a lot of money.